Hello, my name's Lori Prokop, and I am NASA's Software Tech Fellow. And this is the first in a series of software shorts I plan to make that cover a specific focus topic in software or computer science and gives you hopefully under 15 minutes of a talk to understand the topic. This topic is called MCDC. What is MCDC? It sounds a little questionable, right? But MCDC stands for Modified Condition Decision Coverage Testing. And that's a mouthful, but what it really should be called is logic testing. So what it is basically is just a way of testing the minimum set of paths through a unit of software to make sure it performs correctly. It doesn't test all the logical paths, which a lot of people think. It just tests the paths that are meaningful, and I'll go through what that means. So why do it just, at the get-go? So it is, aside from it, it's required for safety critical code in many industries, in automotive, in aircraft, in nuclear, and in space at NASA. The basic reason is not to kill somebody, right? You want to make sure that the code that's running in wherever you are in the automobile or on the aircraft has been tested, and all the logical decisions that could affect your life have been tested. So that's the overall motivation. And what I'm going to go over here is what is a unit of code? And I'm going to warn you right now, I am going to show 11 lines of code. There is going to be code, and I'm going to go through it by way of example. I'm going to provide examples of both forms of MCDC and talk about the strategy in each. So let's get into it. I'm going to go through this by way of some animated PowerPoint. I'm going to give it a try. I hope it works. So MCDC software testing. Some context and definitions. What is a unit? Here's the code we're going to go through. So this whole thing is a unit. It's a function or a method, and it's a snippet of code that stands on its own. This particular function, let's sort of go through what it does. I'm calling it check abort. Imagine it's on a rocket during launch or something, and it receives 3 parameters, and they're all true, false, off course, abort commanded, and valid abort command. Off course would be if maybe the guidance system decides it's not where it should be, if maybe the crew is on board and they command abort, and then you validate that that's a valid command. And then it returns a true, false, assuming it's true, you abort the vehicle. If it's false, you don't. Okay, we'll go through this. The first question you ask is this safety critical? Because that's really where the MCDC is required. Although I'd say, why not do it for all of your code, even if it's not safety critical? It's sort of the right thing to do. But is this safety critical? Yes. So when is this usually tested? You test these units as you write them in general to make sure that they work. So we call that unit testing. And this is exactly when MCDC is done. So how are these functions tested? Well, what you do is call it several times with different parameters for these variables. And you do that each time and verify that the thing is returning what you expect, abort or not abort. And you also verify that all the code in the function has been covered. So why do this? Honestly, just to make sure it works right, and then all the paths are covered. So just a couple more definitions. This is outlined in red is what's going to be called a decision. It's the if statement. And I'm going to talk about these a lot because that's sort of the focus of the MCDC, and the things outlined in green are conditions: off course, abort commanded, and valid abort command. Again, they take on true false values. Okay, now if you look up MCDC in Wikipedia, you will see it has 4 rules, and I will go through each of them. So the first rule is each entry and exit point is invoked. So that means lines 1 and 10 have to be tested. The second rule is that each decision takes every possible outcome. So the outcomes of the decision here are what's after the then and what's after the else, and I have the red lines pointing to them. So you have to test abort and not abort, or true and false. Each decision takes every possible outcome. What that means is that each of the conditions in orange have to be tested to have a value of true and false. And fourth, each condition in a decision is shown to independently affect the outcome. Now, this is the one that causes most difficulty in understanding. You have to say, why I do this? Well, what you're doing here is testing each condition in a decision only when it matters, or only when it actually affects the result of the decision. And I'm going to go through this by way of example. So there's 2 primary types of MCDC. There is unique cause and masking. And in the following 2 slides, I'm going to go through each of them. The first form of MCDC that I'm going to review is called unique cause. And what I'm starting to show here, first I want to draw your attention to the code. From here on out, the only part of the code we're really going to be talking about is the section on this decision with the 3 conditions, because that's sort of what you focus on for MCDC. Make sure you test the combinations of this to cover all the meaningful possibilities. So corresponding to that, I have a truth table here. So with 3 variables or conditions, you end up with a possibility of 8 permutations, what those could be when you call this function 0, 0, 0, 0, 0, 1 up to 1, 1, 1. And that yields 8 test cases. So, and then correspondingly, I put the result of the decision, what it should be. 0 would be don't abort, 1 would be abort for that piece of code. So in MCDC, I'm going to show that the test cases needed to fully test the meaningful paths here are these 4 green ones, where all the possible cases are the 8 in red. So unique cause MCDC, this is the definition. Only one condition when you test it, only one condition in a decision is changed at a time, and you keep the others constant while verifying that the result changed. So here's an example, and I popped up some code here. This represents 4 times that you would have to call this function, and what values you'd have to pass in to fully MCDC test this function. And I'm going to go through this, but what you really need to do is exercise pairs of tests. First 6 and 2, then 2 and 4, then 4 and 3. So you start with 6 and 2, and it has to be in that order. 6 and 2, in those 2 cases, only off course changed, and the result also changed. So by testing those 2 in a pair, you verify that off course independently affects the outcome. Similarly, then the next 2 you take, you had 2, now you add 4, and in that case, everything changes except abort command from a 0 to a 1, and the result changes from a 0 to a 1. So that pair of tests make sure abort command is tested. Lastly, you take then 4 and 3, and in that case, only the last one, valid command, changes. These 2 are held constant, and the result changes. So these 4 tests, actually it's n plus 1, n being the number of conditions. You need n plus 1 tests to do the unique cause form of MCDC, and what it represents is the minimum meaningful set of test cases to do this form. The next form of MCDC is called masking. And you can see I have kind of a similar slide up, but the truth table has changed. So what is this masking form and what's going on in the truth table? The X's in the truth table are what's called don't care variables, because when computers generally evaluate this expression, they'll go through it from left to right, and they'll stop as soon as the decision can be made, right? So in this case, and that's called short circuiting. So in this case, of course, if that's true, you don't have to continue on to evaluate the other two. You can just flag the abort and exit the function, right? So if you look at the lines in this truth table, lines 5 through 8, whenever the off course is a 1, these other variables are marked as don't care. You don't care. Similarly, one in 1 or 2 for the abort command, if there wasn't a command issued, you don't have to validate it, right? So in that case, the valid command is marked as don't care. So masking form of MCDC, what it really does is it relies on this concept of short circuiting to stop evaluation as soon as the decision is made. And in this form, it differs a little bit because the condition under the test changes, but unlike the previous form, the other values, the other conditions here with don't care, they can change as long as they're marked as don't care variables. So it actually allows a little more flexibility, and it allows this number of tests. Any combination of these will fulfill the MCDC requirement. So by way of an example, let's start, in this case, let's start the other way, the reverse direction, and go for the elements in the table that don't have any don't care variables. So you have to run tests 3 and 4 because there are no don't cares. So you run those 2 tests and you call those first, and you validate that the flag is working properly. You get no abort and then an abort for test case 4. And then in the next set of tests, you keep test 4 because that has a 1, and you can pick either of these test cases, 1 or 2, to validate the abort command variable, because these valid commands are don't care, these are 0, and the result changes. Similarly, the third one, you can have either of these 1 or 2, and then you add one of these 5, 6, 7, or 8. And as I mentioned, any combination of those will meet the requirement, and that's reflected in this code by having an X here. You can call these with any either 0 or 1 for these X's, and you can still meet the requirement. So this results in 2 times the square root of n possible tests, which is actually less than the unique cause form of MCDC. And to be honest, this form is really the form, I guess, more that maps better to computers, and it actually is the form that is used if you use a tool like G-code. I have just wanted to flash up further reading and references. There's a good reading there from the FAA, and also each of the standards that require MCDC are listed here. Provide comments where you've seen this or to me directly. And I just wanted to note that I do plan on doing a follow-up video of this for using G-code for MCDC testing, which it can be with a little bit of work, and I'll go through that in the following video. Well, that concludes this software short on MCDC, and I hope you found it useful. If you have any other suggestions for more of these quick videos, please let me know. And with that, have a nice day.